everyone. Thank you for making it here. This is Aitor. I'm the country manager for UK and Ireland in CYPE Software International team. And this is David. David is one of our technical experts on the structural analysis side of things. He travels all around the world, teaching people on how to use the software, introducing companies to it. So David, if you want to quickly introduce yourself.
Thank you very much, Aitor. I'm David, and I'm an architect working here at the Technical Support Department in CYPE. And as Aitor has said, I've been traveling around Southeast Asia lately, spreading the word around the software that we have for structures. And this month, I will be in Thailand, Malaysia, and Singapore. So if you are interested, please let us know in the comments, and we will make sure to get back to you in case we can arrange some interesting events there. And in today's session, we will take a look at CYPE and all the tools that surround it as our reinforced concrete solution.
Okay, so the structure of the webinar is going to be centered about CYPE. CYPE is CYPE solutions for reinforced concrete structures. So CYPE has a lot of solutions for the structures. It's one of the main assets we work on, and we have a lot of different modules to do very different things. We have a module for steel, a module for the steel connections, timber, aluminium, and very different kind of approaches to structural design. But the main frame that we work with is CYPE. It can do pretty much anything regarding residential and commercial buildings, and it will do it really quick and really fast. And that's, I think, the main asset it has. It'll output buildings like no other software in the market. It's really quick, it's really efficient, and the result it shows are really complete. So I think it's one of the main selling points that we can talk about later. So we'll try to be brief. We'll try to be as brief as we can. The webinar is going to be from 30 to 60 minutes. It depends on how fast we can get through it. And we'll show you first the reports, the outputs you can get from the result of the analysis to the actual list of drawings you can get from the building, layouts and stuff like that, to all the different pictures you can take from analysis and results and stuff like that. It will be a quick rundown of everything we can do in that regard. And then we'll jump back to the beginning. I will show you the different avenues you can start the process with, which basically are, if you have a BIM model, you can import information to CYPE. If you have drawings, you can use them as a template and build from there, or you can just start from scratch in CYPE. But most of the times you have some information that the architect or the architectural team will give you to start designing, which is a thing that I'm really interested in. I don't know if you could actually type in the chat how you get your starting points most of the time. If you get a CAD drawing, if you get a good IFC from some of the 3D modelers to work with, if you get a native file from some of the 3D modelers. I'm really interested to know how in different countries the workflows are very different. So if you don't mind telling us in the chat, someone will recompile that information and we'll make a brief, it will be good for us to know how are people working, and it will be, I think, interesting to see how other people start the processes. So from there, I think I'm going to leave the presentation in the capable hands of David. David, if you want to get on, we'll turn off the camera so you can see the presentation in a bigger resolution. And yeah, I think I'll let David run through it. I'll just jump in to highlight some stuff at some points. So David?
Thank you very much, Aitor. I'm going to turn off my camera and I'm going to share my screen. And can you see my screen?
I can. I don't know if everyone else can. Let me see.
Okay. So yeah, with CYPE, we will be able to automatically generate reports and drawings like the ones that you're seeing right here. And the main use cases that we have for this software, as you said before, is mostly for residential and commercial buildings. Let me show you here an example in our project gallery. And you can see that we have from large scale as well as smaller scale projects. Like, for example, we can see here a 54-story high, 200-meter high residential building that's being built right now in Colombia. or even we could use it for smaller scale buildings like this residential one right here, or we can even get to the dwelling basics like this house right here, which is what I'm going to show you today, how you can generate. And of course, when you start these projects, you can either start from a DXF or DWG drawing, or you can reuse a BIM model that has been modeled previously, either with third-party software or even with our very own CYPE architecture, which, by the way, all of this, you will be able to access it through our online platform, which is BIMserver.center. And in BIMserver.center, if we go to the store, we'll be able to access all of the tools that we have for things like air conditioning, MEP, lighting, energy analysis, and of course we have tools for structural analysis as well. And if you want to download CypCAD or if you want to download CyPE architecture, you can do so through the BIMserver.center store. With BIMserver.center, you can also create projects where you will be able to upload all of these IFC files, like what I've done here with this project. And you can see that we can upload all of this data into our project, so you will be able to reuse it later when we are working with our structure analysis software. If you are using a CyPE architecture, for example, we will be able to define a very rough sketch of how our building is going to work, how it's going to look like, as you can see here. And most of the data that we're going to input here is going to be quite bare bones, but that's on purpose. Let me show you why. If I turn off the facade here, you can see that we have some structural data here, beams, columns, slabs, and so on. But of course, these are just basic geometrical shapes. They are not structural analysis model entities, as you can see. And what we're doing is that we are tagging them along with this type that we will be using later when we import all of this data into CypCAD. In CyPE architecture, you can start from scratch, or you can even reuse a DXF or DWG model, like what I'm going to show you right now. And it's quite simple to use software, as you may imagine, because we center on architectural modeling. And not only that, but it's your strong starting point on a project. This will be the beginning of a federated model, if you will. So when you're done modeling your building, including the structure, you will be able to export that to BIMserver.center. And we will be reusing all of this data in CypCAD, as I said. So let's jump into CypCAD.
Let me have a couple of points about the CyPE architecture. So CyPE architecture, I know a lot of people are kind of afraid nowadays of 3D BIM designers. So you don't need a master's to use this software. It's not built to be extremely complex. We know there are other softwares out there that are quite intimidating, but this software is made to be plug and play. You can just right out of the box, just download it, play with it for a couple of days, and I can assure you that you can be proficient with it in a week. Most people here will be structural engineers or BIM coordinators. This software is made for both architects that can go in very deep and generate really fancy renders, but structural engineers can just do the basic structural design of the building. Just get the important stuff. You need geometries, you need floor plans, you need basically everything that's related to the structure. You don't need to build all these fancy furniture stuff, and it's fast and it's quick and it's free. So I think it's a good starting point if you want to get involved with other complex modelers. This is a really complete tool that you can use as a starting point. So I think I would give it a go. It's completely free if you go in BIMserver.center. So even if you're not interested in the structural design thing, this is a really powerful tool and it's completely free. And again, so if you're building BIM models, I think this is a really good starting point. So sorry, David, I'll give it back to you.
Thank you very much, Aitor. So let's continue then with CypCAD. And let me create a new project where we will be importing all of this data. So let's give it a name. And as you can see here, we can link it to a BIMserver.center project if we have an account, that is, which is completely free of charge. And in this case, I'm going to select a project that already contains an architectural definition, as you will see. And now I will be importing all of this data into CYPE so it can be turned into structural analysis entities.
So when we're talking about importing, something important is that the importing is not as strict as it can be in other softwares. It's very flexible. So what I mean by that is, and David will show you in a second, there are a lot of flexible tools to see what you import and how you import it. And later we'll talk about how you can edit and play around with the things you are importing. Nothing is set in stone. It's just you get the relevant information and you just put it inside CAD. But the process is really agile, is what I mean. You will see it in a second. David?
Exactly. We can filter all the elements that we have imported from CYPE architecture or whatever BIM modeler we are using. And we will be able to filter elements like the floors that we're going to import, columns, as you can see here. We have imported this specific kind of column that I tagged before in CYPE architecture. And the software has detected this kind of column and has automatically set up a description as well as a cross-section. You can see that we can customize whatever materials we would like to use. And by default, we will be working with reinforced concrete for sure. But if you want to, you could work with steel, timber, composite sections, and you can even create your own material if needed. In this case, we'll be working with rectangular reinforced concrete sections, but if needed, we can even work with circular, or we can even create our very own, as you can see here. So you could create something very wacky, like what I'm going to create right now. And you'll see that the software automatically gets all the properties for this area. So let's continue in this case with the 30 centimeters by 30 centimeters columns. And you can see that I can either respect the references that I set up before in CYPE architecture, or if I want to, I could rename them accordingly automatically, as you can see here. The fixities for the foundations will also be interesting later when we start defining our foundations. And we can work either with external or without external fixity, depending if we are working with pack footings, pile caps, wrap foundations, mat slabs, and so on. But for now, we're going to leave this with external fixity, with this kind of reinforced concrete column. Same thing for the walls right here. You can see that we can filter them either individually or by groups, and we can turn them into structural walls if needed. In this case, we don't really have any kind of structural wall in this project, so we're going to skip this. And same thing applies for the beams. As you can see, software has automatically detected all the beams that I set up previously in CYPE architecture with all the properties that I set up here. And it has automatically detected that it is a rectangular 30 by 30 concrete section. If necessary, we can customize that, and we can work with many different kinds of cross sections that we have pre-built into the software, like flat beams, rock beams, lattice beams, pre-stressed beams, and of course, even steel and timber. When we switch around, we will see that you can select different kinds of types inside each family. And in this case, we're going to work with propped rectangular beams, but if needed, I could easily work with an inverted T, and I could even set that below the slab.
So I want to point out that CYPE has gone incredibly international in the last few years. So one of the things that we're doing all the time is adding new profiles to beams, adding new design systems from all around the world. There are certain places that do things a certain way, and we're always adding new things to try to be as international, as complete as we can be. There are plenty of construction solutions, so it would be quite hard to find something that we don't do. But if you find something that you work with and we don't have it, we'll add it shortly. We have people working on this all the time, so that's relevant for you. There's information there.
If we carry on, you will see that the second to last step is setting up the floor slab outlines. And if we want to, we can either skip this and we will not import any of the slabs, or we can import the slab outlines, and that way we'll have a basis to set up slabs that we're going to design. Because for an architect, the definition of a slab, it's different to what a structural engineer may require for structural analysis. So instead of forcing a view on what constitutes a structural element, we give you the opportunity to completely set this up in CYPE as well. For example, you can see here that I have this slab, and maybe for an architect, this slab ends right around here where we have our rendering for this part of the slab, but maybe for a structural engineer, this will end more or less around where my cursor is, because you have to take into account the depth of the rendering, if you have any kind of insulation for the thermal acoustic analysis and so on. So that's something that we could take into account as well. And in this case, I'm going to import the outlines so I can work around that and customize it to my liking. And here, as the last step, we can import the different walls that we have, but not as load-bearing walls, but instead as construction elements that will interact with the structure. That is, walls that will be turned into dead loads, as well as loads that will interact when we are analyzing the wind, as well as seismic analysis. In this case, I'm only going to import the facade, and I'm going to forget about the partitions, because the partitions, as you may imagine, will technically be a kind of live load. So it is best to treat them as a uniform load instead of a linear load, which is what the software will do automatically for us. So let's click on finish, and let's start our project as we will regularly do. As you can see here, we can set up the building codes and the building materials, as well as the loads that we're going to set up in software. For the codes, you'll see that we have the building codes from all around the world. And if you want a complete listing, you can take a look around here. We have building codes, including but not limited to the Euro code, American standards, British standards, and of course, many more from around the world, as you can see here.
Again, same thing as sections. We were talking before about materials and construction solutions. We're adding new norms all the time. If norms change, we need to be on top of it. So if you find any norm that's not in there, in the whole structural side, we have a lot of them. But if you found that you are from a country that have a different norm, let us know. It's always interesting to keep adding stuff here. But nowadays, we have pretty much every relevant norm in the world in here. And David will show you how easy it is to switch from one to the other. Even you can calculate the same building under different standards. So I'll leave David to it, but you'll see in a second how easy it is to change norms.
Indeed, if necessary, you can take your building and you can change the code for your final analysis on the fly. In this case, I'm going to work with a Euro code if you allow me, but of course, if necessary, we could change it on the fly if we wanted to work with, let's say, the British standard, or if we wanted to work like with, let's say, with the American standard and so on. So it's quite flexible in that sense. And once we have the building codes for all the materials for concrete, steel, timber, aluminum, and so on, you will see that the materials update as well. We work with a predefined series of concrete as well as steel materials for the reinforced concrete. But don't worry, if we don't have the concrete or the steel that you're going to use, you can always create your very own, as I'm showing you right now. And it's just as easy as setting here a reference for this material as well as the characteristics for the analysis. And you will be able to get response curves like the one that you see right here. And like that, I will be able to link this specific kind of concrete and the like to the rest of the materials I want. But for now, we're going to continue with this. And once we have the building materials that we're going to use for our reinforced concrete as well as for our steel sections, we can continue with the loads that we're going to apply. And we can apply a uniform live load and net load throughout all the building levels that we have. So we can do something like this, as you can see. And same thing actually applies for the rest of the loads that we're going to have.
Regarding loads, we'll talk about it a bit later, but we can put loads in specific places in the structure, right? When we get to it in different beams, different columns, we can put very specific loads. And I found that relevant because you can bring information from other softwares here. If you design the metal structures, if you are designing, I don't know, a timber roof structure that's going to add a significant amount of load, you can add that on top later. It doesn't have to be here.
Exactly. By default, the software automatically takes care of the loads for you. And if you want to have automatic wind loading or seismic loading, that's something that you can do as well. It's just a matter of selecting the wind load code that you're going to use, setting up some basic characteristics so you can start working with it. Things like, for example, the reference speed, terrain category, land orography, service period, and so on. As you can see, this is customized to whatever building code I'm using. And same thing applies, of course, for seismic loading as well. We even have some maps pre-built into the software if you want to get the standard values according to the maps provided by the standard codes. Let me show you here, for example, for the wind loads. So it can be easier for you to set up these as well. Now that we have our loads ready, we can continue with the actual design and analysis. We have all the loads and all the levels ready. And of course, we have to check the construction elements that I have imported before, because if you paid attention, you may have noticed that I have imported some walls, some facades that will behave as a dead load, but they can also interact with the rest of the structure in the seismic analysis. That's something that I can set up here. I can either put all of these values manually, or I can work with some of the pre-default values that we have. So I could do something like this, for example, and you can see that all the seismic analysis properties as well as the surface load has automatically updated as well. And here we are greeted with the main interface for CYPE, and you can see that we work mostly with 2D views. We start first with the column definition, and then we can continue with the beam definition and so on. And right now we have something like this out of the model that we have generated previously with our BIM model. Let me show you here a side-by-side comparison so you get the idea. So we've turned this architectural model into this structural analysis model, all with the help of this wizard that we have integrated into CYPE. So most of the dirty job is already done. You only need to set up things like the panels, the foundations, and so on, and we will be ready to analyze. Let's start first with foundations. So let's go down a level, and you can see here that we already have a template that has been generated automatically from our BIM model if necessary. We're going to turn this off for the time being. And in CypCAD, we can generate many different kinds of foundations. We can work, for example, with either single column or multiple column elements, things like pad footings, pile caps. And as you can see, we have many different kinds of pile caps as well as different piles that we can create for that as well. And when we change to the 3D view, you'll see that we already have our pile cap as well as our pile as well. But in this case, what I'm going to do is I'm going to work with a pad footing system with strap and tie beams. So instead of having to draw this by hand, I'm going to generate all of that automatically, as you will see here. And now we have something like this. You'll see that the strap beams, the tie beams, and the pad footings may look a little bit funny now, but that's because we haven't analyzed them yet. If necessary, we can complement this with more strap and tie beams, which is what I'm going to do right now. You can see that we have a library already pre-built with all the strap beams and tie beams that you may need. And it's as simple as drawing your existing elements like so. So once we're done, we will have something like this. And now we are almost done with the foundations, but as I said before, we have more elements that we could work with.
Okay, so you did a couple of really interesting things there. First of all, we were talking about how the software automatizes a lot of the processes. But here, you made some changes to the layout that the software was giving you from the actual layout that was provided by the architecture software. So you added a couple of foundation lines there. C1, I can see. So there's a lot of ways to edit in the process of designing the building, right? When you're already designing the structure, you can on the fly change things, add things, remove things. That's correct, right?
Exactly.
Okay, so that's relevant because you are not forced by the template that you used. Everything is flexible. Everything is editable at any point in the process. That's one thing. The second thing is many people at this point in the presentation, many people when we are doing demos with companies and stuff, they talk about grid lines. I know some other softwares use them. We are not seeing them here, but I assume that we have them considered.
Well, what you're seeing here, these reference lines, could be turned into grid lines if necessary, and you can have both vertical as well as horizontal grid lines. So let me insert some of them so you can get an idea. Maybe we could start here, sorry, not this one, but let's say, for example, here we could have an horizontal one, which we can name however we want. So for example, this could be A, and you can see that it automatically continues B, C, D, E, and so on. And this data will be reflected later when we export all of the automatic drawings as well. Let me add, for example, some vertical lines as well, so I can have 1, 2, 3, 4, and so on. And you can see that we can turn these reference lines into these grid lines that we are talking about.
Okay, so it's not that they cannot be done, it's just that they're not done by default.
Exactly, that's something that's left for the structural engineer, for the architect to decide.
Okay. So regarding foundations and columns, we didn't talk about retention walls. I assume they are not relevant for this project, but many people are interested in how they are input in the project. So if you could just make a small one or show how it's done to show that it's there, mainly. And we'll talk about masonry wall in a second. But
so for structural walls, if you paid attention before, we could import many different kinds of walls off of the architectural model. And in CYPE, we can have reinforced concrete walls, plain stress walls, reinforced concrete block walls, as well as masonry walls. When we insert a reinforced concrete wall, we will be able to set up the physical properties as well as the pressure diagrams that will affect the sides of our walls. So let's create a new pressure diagram for this wall right here. And you can see that we can set up different situations. So the software can detect the worst case scenario for each situation. And of course, we can set up these physical properties either manually, or we can set up this as well with the typical project values that we have prebuilt to the software as well. So we could have something like this. We can even have water tables as well as even rock levels if necessary. So we could have a default pressure that could look something like this when we apply it to the left side of our wall. Let me edit first the pressure diagram once more. And we can see that it's as easy as throwing it freely into the space. And we will be able to have concrete walls, plate stress walls, reinforced concrete blocks, and masonry walls that will have either a direct fixity for the foundations or strip footings with or without soil interaction, with overhangs on one side or both sides, as you can see here. They can even have a foundation beam if necessary if we want to, for example, design a mat foundation. So we can use the walls as a founding element for that panel. And now that we're talking about panels, I'm sure that you've noticed that now we are only missing the panel information that we are designing here in CYPE. So let's go to the upper floor here on this level. And you will see that by default, we have imported all the different panels as empty spots here as openings, and we can turn this into panels with the help of the panel manager. You'll see that by default, we have many different kinds of slabs, like for example, joist floor slabs, hollow core slabs, composite slabs, waffle slabs, both with lost and removable, as well, of course, as flat slabs, which is what we're going to use for this case. And we're going to set the depth, and it's just a matter of selecting the founding element to insert the slabs as I'm doing right now. Let's continue with the upper floor. And we should have something like this. You can see the structure is almost ready. And once we're finished with the slabs, we can continue, for example, with the loads. You can see here that all of these linear loads have been imported automatically from the walls that we've defined before in CYPE architecture or whatever BIM modeling we're using. And if needed, we can manually add loads as well. We can have point loads. Let's say, for example, that this client has a very heavy statue on his living room. Or we can have line loads, like what you're seeing right here for the facades. Or we can have even surface loads, which could be used, for example, let's say that we are designing a parking space. So maybe this could be the weight of a specific car, like this. So once we are done with the loads, we will be able to analyze our structure with a click of a button. I'm not going to bore you, so I will show you the final result here. And you can see that it's the exact same structure analysis model. And with the click of a button, I've already analyzed all of that. So let's take a look here at the results. And you can see that we have the river automatically designed for all of our elements. Let's take a look here. And you can see that CYPE has automatically designed all the traverse as well as longitudinal reinforcement for this BIM, as you can see here. But of course, if I'm not happy with the final result that CypCut has offered me, I can always edit that to my will as well. I could add things like the lens, as well as the diameters and number of rebar I'm going to use for each one. And you'll see that the sections update automatically as well when I do this. I can even add, for example, skid reinforcement. And you can see that the sections update accordingly as well. And of course, we can even take a look at the full analysis of all these individual elements, like so. And when we're done, we will be able to export this, if necessary, into a PDF, HTML, Word format, or whatever it is necessary. You can see it's being generated right now in real time. And this could be part of some of the reports that we're going to generate with CyPE.
One of the good things that Cype has that not many other softwares do, we show you most of the formulas we're using. We show you the analysis. So it's not only about many other softwares just have the upper window. They give you the check, the verified, the okay, but we'll show you the innards of what the analysis is doing. And in many regulations all around the world, many building codes, you have to show many of the innards of what's going on. So it's relevant many countries to have this information shown, so it's there. We believe in just being open about what the software is doing behind bars, behind doors. So it's there if you need it, and it's easily accessible, and it will be output when you generate the results.
And of course, if I input something silly, like let's say that I wanted to get rid of some of these diameters and put something smaller, I could always take a look here at the checks to see if there are some checks that are failing, and I can see why it's failing, so I could easily address the issue on my own. Or I could just easily rebuild the frame and get the predefined rebar that CypCut recommends me. And same thing applies, for example, for columns, as you can see here. Software automatically groups the columns depending on the properties that each one of them have. And we can take a look at the description for each one of the sections for this arrangement. So we can change things like the anchorage and splice lengths, or we can change the disposition of the specific stirrups. We could put bigger stirrups, or maybe we can have cross ties, close ties, and so on. And we can even work with a predefined set of layouts as well, if necessary. And at each step, we will be able to see all the checks that we've carried out. Just like we did before with the beams, basically. We can have a 3D view with the results, as you can see here, where we can visually inspect either individual elements, like what you're seeing here, or we can have either a full view with all the rebar that has been generated by CYPE. Mind you that all of this has been generated automatically. I haven't drawn a single line of rebar up until now. And this is the final result that we get. But of course, we need to show all of this into drawings that could be used in the actual construction site. So that's something that CypCAD can also do on its own. All the rebar that we are seeing for beams, columns, slabs, butt footings, strap beams, tight beams, and so on, can be easily exported into automatic drawings. Let me show you here. We can generate drawings that we can later export, if necessary, into the XF and the DWG files. And as you can see, we have many different kinds of drawings by default. Things like column detailing, column schedules, prints drawings, layer plans, and so on. We can customize things like the scale, references for all the tags that we're going to have, and even things like the pen thickness and the text width, because this is something that will be taken into account when we automatically generate the layout for all of these drawings. You can even add title blocks if necessary, and this can be easily customized if necessary as well. So let's generate these drawings now.
Many people already have their own templates in AutoCAD and stuff like that. I assume that you can just output the drawings and those can be added into their already made templates. I assume that this process will be easier just to make templates here, but many people are really comfortable with their already set templates. So I assume this whole information can be outputted as DWGs or DXFs, so they can be edited in some other CAD tools to add them to the already made templates. Is that right?
Exactly. There's some clients that prefer to work directly with the layouts and templates and so on that we can generate, like the ones that I'm showing you now. And there's some people that prefer to export all of this data into a DXF, DWG, or whatever to edit it with third-party CAD tools. It's up to the end user, as you can see. But of course, we generate the full drawing, as you can see, both the layout as well as the actual details for the sections, the rebar, traverse, longitudinal, skin, stirrups, even if necessary, as you can see. And of course, it contains all the data, so we can send these drawings to the construction team, and they can have a hands-on experience from day one. We can even have things like, for example, custom scallops, like this one right here, with even some basic bills of quantities, as you can see, and even some bending schedules. And of course, before we've inserted these grid lines, so we can reuse them later if we want to for our floor plans, like the ones that you're seeing right here. And when we're done, we can print all of these into one file or multiple files if necessary. So we can have something like what we've shown you at the beginning of this presentation.
So now that we kind of finished the whole design and analysis process, so one of the main assets of CYPE is that it takes away a lot of the busy work, right? So most of the engineering here, most of the engineering being done is defining and just specifying what constructive solutions you're using and making sure that everything is working, right? So how much, if a project is 100 hours, how much would you say CYPE is cutting down the time to? Like, what percentage of the time is CYPE saving, more or less, in a real project?
I'd say roughly 80% of the job is being taken care of by the software. Because if you think about it, we are automatically setting up all the materials from the BIM model. We are carrying out the analysis and the design. We automatically generate the reports and the drawings. So basically, the engineer's job is just to fine tune the structural model and just focus on the structural decisions per se, and the rest is being taken care of by the software, basically.
I like that expression, fine tuning. Yeah, pretty much. So that's where the expertise comes in, and the rest is being done by the software, and it's efficient. And it's a thing I mentioned before, and I'm making an emphasis here. It is really efficient, and most of the things we've done here were done automatically. Okay, so the webinar is going a bit too long, so we're going to try to summarize the second workflow, the whole importing from CAD files. So what we're going to do is we're going to go back to importing a template from CAD to start working here. And we are going to make it just a small room. I will show that the option exists. We'll show what the process is to get the templates going and how to input columns and beams and stuff like that into the templates or on top of the templates, to be precise. The setting up process is the same. We're using the same panel we were using before. Just instead of using a 3D model, now we're using a 2D CAD file. So from there, we'll just get in and start working from there. There is a couple of things I wanted to mention in that regard. I'll wait for David to get there, but AutoCAD is really finicky with scales. You need to be really precise, and a lot of CAD modelers are the same. So our tool has options to rescale the CAD files you're getting in. You may get a CAD file with a certain scale problems or difference or gradients that can be adjusted here. It can be rotated. It can be worked here a little bit, which is relevant because many people just get the CAD file and just want to start working, so they don't need to go and run through their CAD file to adapt it and make it work here, which is relevant. And from here, you have the template, you have the relevant information there. And another thing that's important to mention is a lot of buildings are really similar vertically in that they have groups of floors that are basically the same thing. So one of the things this software does is it allows to have different types of floors, and you only define them once, and it just tell how many floors there are of that type, which is really, really important because when we're talking about one or two floor room buildings or residential buildings, small residential buildings, this might not be that relevant. But when we jump from, I don't know, 20 floors in which only 2 or 3 are different, is really, really relevant that we can actually just design one and export it 19 times. That's important. So what David is doing here is just using really familiar, I guess, if you're using CAD systems, parametric drawing to just get elements there to actually start working. And it's just like any other CAD modeler. You'll get you can get the beams, you can get the columns, and from there you can pretty much just set up the same structure we were using before. It will be a bit slower. So these processes, well, obviously BIM has its advantages, so it's not going to be as fast as React, but it will be that much slower. If you are agile with this kind of tool, you only have to input where the columns are, and there will be a lot of work being done by the software too. So I'll let David work really quick on the background, and I'll mention a couple of things regarding licensing that will be relevant, and I'll just mention them so you know where the software is regarding price, and you are then how the licenses work. So CYPE works with full owned license systems, which means once you buy the software is yours forever, and you only need to pay for new versions. What it means is if the software cost, in this case, CYPE is 3,800 euros, there will be obviously a discount for the event for like a few weeks after it. So if you're interested, contact your local salesman or distribution company, or just contact any of the salesmen that are in the chat, or you can search through LinkedIn and add any salesman from CYPE and they'll help you. And they'll get you in touch with a local distribution company, or they'll just help you directly. The discount is going to be there, important. The price is different from different countries. I know some countries have different price ranges because of many different things. So if you find that relevant, it's there. It's information you may use at your leisure, and we'll help you see, assess what the needs are and what we can do to help. We have a lot of software that does a lot of things, so maybe you will be interested only in the structural side of the concrete side of structural analysis. We have other tools that may ease your workflows, so there's that. And yeah, I think David is kind of finishing his process here. He just rebuilding the same structure we were doing before. What's being shown here is that if you have a template, you can work really fast too. And many people are really comfortable working with CAD files. I'll check in a minute how the poll went for the how do you get your projects, what format you get your projects on, but many people get CAD files. So this is a way to easily just output a 3D model of the structural design and analysis, which would be really relevant. I don't know if you want to add anything, David, while you design. I see you're working really hard on the background, so I don't know if you want to mention anything, if you want to make a point of anything I'm saying.
Well, right now we are almost done, as you can see. We are just missing some panels to be defined here. So let's very quickly define our panels like what we did before. And once we are ready, we will be able to analyze and get the reports and drawings just like we did before. Let's take a look here in the 3D view. So you can see that the building is starting to take shape. Now let's fix this right here, and we will be able to analyze our structure with the click of a button. So once you feel comfortable enough with the software, you will be able to basically model a building like this one in an evening and get the results in less than a day. Is something that will speed up the development of your projects and overall just improve the throughput of your practice. So we have this ready. So let's click here on analyze.
Another thing I wanted to mention here is David and I are working from home. So the computers we have are pretty much just laptops, office laptops that we brought home. This software can work in pretty much any computer. It's a really lightweight software, so it will just work in pretty much any computer. Calculations time may vary. As everything else, if you have a really good processing computer, it will work faster. But it is quite fast for what it is. And if you have a decent desktop computer, it will do things in a flash. So that's relevant too. But the main thing I want you to get is it works with pretty much any system out there. So I think it finished the analysis already, and we're back to the rebar visualization tool. So again, we wanted to emphasize that we're doing the same thing in different ways. So this is the same information we had before, pretty much. And well, David is really proficient with the software, but you could see that he did the whole thing in the 3 minutes I spent talking about licensing and stuff like that. So it's fast. It is fast. So he will add some results now. You can define the output you want for a lot of things. There are default outputs, but many countries have different building codes, many different things they may have to output. So regarding drawings, most countries need them, and of course for the construction side, they're important. So you can define your own results for most things. There you go. That looked good. And here you can see the drawings and the technical information of the rebar, which will be incredibly useful when you are in the construction site. Also, all of our tools have visualization tools. We have augmented reality and virtual reality tools, and you can visualize the 3D models in the BIM server. So if you give access to the construction company, the construction company, the contractors, to this software, they will easily be able to see every layer of information that's connected to the file in a 3D model, which is incredibly useful. It's not being used that much nowadays because BIM is a bit new and contractors are taking their time to adapt to it. So there's a lot of 2D drawings going around. But if there is any doubt, if there is any trouble interpreting or working with those files, you can always go back to the BIM server and just give them access to the project, and they'll be able to see the augmented reality tool is quite impressive. You can project into the actual construction sites what you're doing, so you can see what's going on in real time. And if you can show David the projects and the different layers, it's loading. Okay, fair enough. He has to download every single layer to show them. I think the augmented reality is going to become a standard in construction sites. Many companies just do that. And it's other of the free tools that you can get at BIMserver. We sell the software for analysis, but pretty much everything else is free. Visualization tools, the server itself, you can have as many projects as you want. I think there's a limit of volume of information, but it's wide enough so you don't have to worry about it until you've been working with it for a while.
And not even that, now it's completely free of charge and limitless. So you can start using it right now. You can create a free account. You can try out all the software that we have, and you can reap the benefits of working with multiple people at the same time with infinite storage space.
Oh, there you go.
Of course, with the visualization tools that we were talking about before. So you could easily just filter throughout the different layers that we have and use this as a collaboration tool to generate your federated model.
Can you show the rebar only so people can see that you can actually give them access to the rebar so people can see how the actual rebar is in 3D? And I think that's a really interesting tool. So I think that's pretty much everything I wanted to comment. I don't know if you want to mention something else, David.
Well, of course, all this data that we are generating can be sent back to BIMserver.center, which is what I'm showing you right now. And when you link it and you export it to a project, you will be able to get the 3D view as well as the actual BIM model in our 3D viewer, which is what I'm showing you here. When I click on any of these elements, I'm getting the actual data from the BIM database.
That's probably useful. Okay. So I think that's it for today. We showed pretty much the whole workflow you can do in CYPE. There are a lot of small things you can do around it, a lot of different analysis. We didn't show the window where all the analyses are in CYPE, but there are a bunch of them. I don't know if David, you can quickly go back and show. You don't have to go in them, just show that they exist. There are a lot of different plots that you can make with a lot of different analysis and a lot of different requirements or specific quirks that you may have to check for your specific structure. So there are a lot of tools here, but the main thing is how fast everything goes and how smoothly you can go from time to time, to window, just checking and changing and making things. The end result should be just how fast everything goes here. I think that's the main thing I want people to remember. So yeah, that's CYPE. I think the presentation was really complete. It took a bit longer than I expected, but it is what it is. CYPE is a really complex software. Not complex in that it's hard to learn, but complex in that there is a lot of stuff to see. So I don't know if David wants to show something else. If not, we'll put back our cameras to goodbye. And pretty much that was the presentation we had for CYPE. It was a really interesting presentation. I think you will have the comments in LinkedIn. If you're connected through GoToWebinar, you can leave comments there too. And we'll try to answer them as soon as possible. If we are not able to during the presentation, we'll send you an email later. In GoToWebinar, you have to sign up with your email. In LinkedIn, please give some contact information. We will contact you either through LinkedIn or contact information if you leave any. And yeah, I think that's pretty much it. Thank you for your time, and I hope it was interesting to you. Thank you.